This is a video about naming compounds that are acids. I know something is an acid if it starts with an H. So if I look at the formula and it says H and then the Cl atom, I know this is an acid because it starts with the H. If I see one that is HBr, same thing. If I see H2SO4, I know these are all acids. Now, the three I've written there, the first two are binary acids. And you remember that binary means two. So we've got a hydrogen ion with an anion written there from the periodic table. All right, so these are binary. This one down here, it has that SO4. If you remember, that's a polyatomic ion called sulfate. And so these are called tertiary acids, or sometimes called oxyacids, because they're going to have oxygen in them. All right, so there are two different methods for naming these, or a method for naming binary and a method for naming polyatomic ones, acids. So let me start with the binary first. You may already know that HCl's name is hydrochloric acid. So this is a good one to start with. How did it get its name hydrochloric acid? Well, what they did was they took the chlorine to be the root word. They put the prefix hydro. They put the ending ic and the word acid. So if you have a binary one, you always go hydro, the base, which is the anion's name, put ic on the ending and write the word acid. So therefore, if I go HBr, this is hydrobromic acid because this is bromine. So this one's hydrobromic acid. We could have H2S. I need two hydrogens to the one sulfur, but it doesn't matter that I need two hydrogens. I still follow the same rules. The anion is sulfur, so it's hydrosulfuric. Little bit of change there at the end. Acid. Right, so that's how we name binary ones. Now, if I have the name let's see, hydronitric acid. How do I go back? Well, I know it's an acid, so my positive, my cation is going to be hydrogen. I look at the root, it's nitrogen. I look on the periodic table, nitrogen is in group 15, so it's 3 plus. So the formula for this is H3N. So these are binary acids. Let me show you what to do when we have an acid with a polyatomic ion on it. For instance, I'm going to start with this one, H2SO4. Let me pull that down so you can see it. H2SO4. This is a polyatomic acid or a tertiary acid or an oxyacid because they're going to have oxygen in them because they're going to have a polyatomic ion. So right away I see this polyatomic ion. I know its name is sulfate. So I've got to know the polyatomic ions, sulfate. If your polyatomic ion's name ends in 8, its ending gets changed to ic. So this is sulfuric acid. All right, so the 8 ending gets changed to ic, sulfuric acid. If I have HNO3, I have to know this polyatomic's name. It's nitrate. Again, the ending's going to change to ic, so I get nitric acid. So my ending's changed. I could have H3PO4, and again, I'd have to know that this polyatomic's name is phosphorate. Good. And I'm going to change this name to ic, the ending to ic, and so I get phosphoric acid. All right. Now, what if the ending is not 8? Well, I'm going to go to H2SO3. remember this was SO4 up here, we're going to go to SO3. I'd have to know that this one is instead of sulfate, it's sulfite. If it's ite ending, that gets changed to us. So this is going to be sulfurous acid. And again, I'm going to use this one right here, HNO3, I'm going to write HNO2. Instead of being nitrate, this is nitrite. And so it's going to get changed to the us ending, and so that's going to be nitrous acid. All right, so you got to know your polyatomics in order to change the endings. Now you'll notice none of these are hydro. The hydro prefix, that goes with the binaries. So no hydros here. We just change the ending, the ate ending to ic. So ate goes to ic, and us goes to, ite goes to us. All right. And so that is how you name acids.